Okay, in section 9.3 we're going to be dealing with weight and mass. Okay, weight is the measure of gravitational pull on an object, whereas mass is the measure of quantity of matter in an object determined by its molecular structure. Okay, in this section we'll treat mass and weight as equivalent and refer strictly to weight. Okay, so even though there is a scientific difference between the two, okay, we're going to treat mass and weight the same in this particular section. Okay. So, again, just like we did in the previous couple sections, we're going to be dealing with units of weight in the English system. Okay, ounces and pounds have a relationship. Also, pounds and tons have a relationship, 2,000 pounds per 1 ton. The metric system is not surprising, hopefully. It's going to look exactly the same as what we had with meters and liters, except for the weight of the weight measurement in metric system is grams. So everything is based on 1 gram, and same prefixes, same amounts, as we can see here. Okay. So changing units in the metric system is going to be the same thing that we did for meters earlier. Okay, if we want to go from milligrams to grams, okay, we'll start at milligrams and we'll move 3 steps to the left, okay, which means that we will move the decimal 3 steps to the left also. So 950 milligrams is 0.950 grams. Okay. Couple more. Volume and weight measurements here. Volume and weight of water. Okay, particularly, you can keep in mind that this is just water. If we had some substance that was heavier than water, okay, or lighter than water, okay, some other element, okay, some other mixture, okay, it will not be the same as these. But ultimately, 1 kilogram of water has a volume of 1 liter. Okay, so conversions here. So again, weight of water in the metric system. Okay. One thing I want to note on this one too is that if we have a meter cubed of volume, that's the same as 1 kiloliter, okay, which is the same as 1,000 kilograms, which is the same as 1 T. Okay. Now, if we look at a conversion here, we have 0.25 meters cubed of water. How much does the water weigh? So if we want to change it to kilograms, okay, we know that 1 cubic meter is 1,000 kilograms. Okay. And if we were to do the math on that, of course, we'd multiply by 0.25 times 1,000. We'd get 250 kilograms. Okay. So if we have 1 cubic meter of water, that would be, or excuse me, 0.25 cubic meters of water, we get 250 kilograms. Okay. Okay, some conversions between English and metric here. 1 ounce is about 28 grams. 1 pound, about 0.45 kilograms. And then 1 ton, the ton that we use, okay, is about 0.9 tons, they call it. Sometimes called a metric ton as well. So in this particular case, we want to change 160 pounds to kilograms. So same theme, pounds on top. Pounds on the bottom will cancel the pounds, bring in kilograms, and we know the relationship between those two is 1 pound to 0.45 kilograms. And so if we multiply there on the top, we're going to wind up with 72 kilograms. So you notice this dimensional analysis that we're doing, which we'll do the entire time in this chapter, okay, it never changes. Okay, if we want whatever we want to get rid of, we put on the bottom to cross it out. Whatever we want to bring in, we bring in. Okay, and then after that, we do the math. Okay. The other thing we're doing in this section is temperature. Okay, there's a couple of key elements here between the Fahrenheit and Celsius temperature scales, water freezing and boiling points. Okay, we hopefully know those from science already. And then converting, we have 2 formulas. One is the Celsius to Fahrenheit, and then the Fahrenheit to Celsius. Okay, so we have 2 formulas here that we're going to use that convert between one and the other. So in this particular case, if you look at the example I have here, this is the bills from the European vacation. Have you feeling a bit feverish? So you decide to take your temperature. The temperature reads 37 degrees Celsius. Should you panic? Okay, ultimately, if you take your 37, you put it in there, you get 98.6. And so the answer is no, because 98.6 is normal temperature. So normal temperature is 98.6 Fahrenheit. Okay, and so you should not worry in this particular case. Okay. Similarly, if we knew the temperature in Fahrenheit and we want to change it to Celsius, we could plug our 77 in for Fahrenheit and do the math, and we get 25 degrees Celsius. Okay, would be the equivalent to 77 Fahrenheit. Okay. Okay, we do have a Kelvin temperature scale. Okay, absolute 0 is the coldest possible temperature at which there is no heat and molecules stop moving. Okay, that's 0 Kelvin. and that's actually negative 273.15 degrees Celsius. Okay. And then in Kelvin, the boiling point of water is 373.15. Okay. And we do have conversions between Celsius and Kelvin. So if we want to go from Kelvin to Fahrenheit, we could of course change to Celsius first, okay, and then change Celsius to Fahrenheit. Okay. All right. So here's a comparison of the three temperature scales. Okay. Water boiling for Kelvin, Celsius, and Fahrenheit, water freezing, so on, and then absolute value, okay, or absolute zero, that is, absolute zero Kelvin is that many degrees Celsius and that many degrees Fahrenheit, so awfully cold to get to that absolute zero.